All right, so let me start sharing my presentation here. And then I think I need to swap my screen, so bear with me. Okay, so hopefully everybody sees the full screen there. So my name's Karl Feucht, and I'm with Benjamin Obdyke. And of course, we'll talk a little bit more about who Benjamin Obdyke is later. Just a quick bio about me. I've been with Benjamin Obdyke for about 11 months, but I've been in the building materials industry for about 15 years. Love talking about building science and kind of getting into the nitty gritty of how things are built and how everything works together. I cover the Mid-Atlantic for Benjamin Obdyke. I live in Lancaster County, Pennsylvania. Have 4 kids, and they keep me busy. And you know, in my spare time, I enjoy being out in the woods, in the mountains, trail running, hiking, things like that. So never a dull moment with 4 kids and a couple of hobbies. But yeah, today's presentation, it's called Drainage and Drying in the Exterior Wall. And it's worth 1 Health and Wellness CEU. Yeah, these first few slides here are just kind of your boilerplate AIA slides. So I'm not really going to spend a lot of time talking about these. Our learning objectives today. So you're going to hear me talk a lot about this first one. You might get tired of hearing me use the word gap, but we're going to talk about why it's important to build with a gap in our exterior wall assembly. And just a quick definition, when you hear me say exterior wall, it's anything from the sheathing out. That's defined as the exterior wall assembly. We're going to talk about the difference between a drainable house wrap and a rainscreen system. A lot of times those are used interchangeably, but there are some important distinctions between the two. And we're going to talk about not just the differences between the two, but when we want to use which system. Because there are a variety of factors we want to consider. And then we're going to talk a little bit about how some of these products are installed. So this first slide, I like to talk about this slide here for a couple minutes because it kind of just lays the groundwork for the whole presentation. So I want to talk about my house for a second, all right? So I live in Lancaster County, PA. I live in an old farmhouse that was built in 1908. So my old farmhouse is not very good at the left side of this screen, right? You see the picture with the guy, the caulk gun, he's air sealing around a window. My house is not energy efficient, right? So my house is drafty in the winter. You could put your hand on an exterior wall from the inside and it's cold. You know, there's no air sealing. There's no rigid foam insulation on the outside. There might not even be any insulation in the exterior walls. So my house, my energy bills aren't the greatest. However, one thing that my house does have going for it is I don't have any moisture in my walls or moisture issues in my walls because my house can breathe really well, all right? So back in the, I'd say 70s, 80s, up to today, we've really changed a lot of how we build homes now. We're focused a lot more on being energy efficient, and that's a good thing, right? So we want to reduce energy consumption, which is good for the environment. It's good for, you know, keeping expenses down, utilities down, makes our homes comfortable. You know, now homes, of course, come standard with HVAC units. So we want to keep our homes cool in the summer on days like this, and we want to keep our homes warm and cozy and comfortable in the winter. And we've even gone so far as now we're talking about things like net zero homes and passive homes, and we're doing blower door tests and all of these things. And these are all really, really good positive developments over the past 2, 3, 4 decades, right? As we focused on the left side of the screen. However, when we're building our houses so tight, now when moisture gets into the wall assemblies, which it does, it's inevitable, we'll talk about that, where is that moisture going, right? Now our walls don't naturally breathe the way the walls in my house do. Our construction methods have changed a lot in 120 years, right? So now we need to start focusing more on the right side of this picture, so the right side can kind of catch up with the left side. I hope that makes sense. And don't worry, I won't spend that much time on every slide today. So we're going to talk about some different causes and factors of moisture-related problems. And there's a bunch of different moisture sources. We're familiar with them. rainwater, this part of the country, I mean, we've had it, what, the last few days, we get these major rain events, right, where a storm goes through and we get wind-driven rain. And it just pelts the side of our structures. We get moisture in the air just with humidity. So naturally, there's moisture around, there's groundwater. And then this is a big one that I'm going to spend a couple minutes talking about: moisture in materials. Okay. So if we were in a smaller setting or in person, I would ask for some volunteers to try to make this a little bit more interactive rather than just listening to me talk. But I would ask the question, does anybody know what a reservoir cladding is? So it's a pretty important term. Another word for that might be absorptive cladding. And cladding, of course, is another word for siding. So a reservoir cladding is any siding material that absorbs moisture, right? So there's a bunch of them that we use every day in our industry, and they're great materials. It doesn't mean that they're bad, right? So the picture you see there, of course, is an example of stone. So anything masonry, stone veneer, brick, stucco, those are great examples of reservoir claddings, but there are a lot of others. Wood, anything cedar, engineered wood products. So something like an LP smart side or a boral, which is a composite fly ash. Those products also are reservoir claddings. And one of the biggest that we use today is fiber cement. Beautiful product, but it absorbs water. It doesn't make it wrong, but as water gets in, we just need to be aware that we're building with materials that introduce water into the wall. Water gets in through joints where two materials come together, and that's where we want to have attention to detail with our kick-out flashings, things like that. Penetrations are big, right? So water's going to get in. Our biggest through penetrations in our walls are windows and doors, right? Our major fenestration points. And so fasteners, these are all ways that water can get in. Essentially, whenever air or vapor can flow through a wall, moisture can also get in. And there's a lot of different things that drive the moisture. I'm not going to spend a lot of time on this slide. You could do a course just on this slide alone here, right? There's a bunch of different driving forces. The couple that we'll talk about today the most are hydrostatic pressure and capillarity. And there's some slides that'll talk about this a little bit more. So this quote, it's from John Straub in the ASHRAE Journal back in January of 2002. I'm not going to read the quote, but essentially what he says here in this quote is that the rate of drying needs to be greater than the rate of wetting. I don't know if that's a technical term or not, but it's how I put it. So our walls need to dry faster than they get wet, essentially is what he's saying here. And so got some pictures of what happens when that is not the case, right? So believe it or not, most moisture failures that we see in homes are in homes that are less than 10, 15 years old. So the home on the left here, that's a pretty extreme example, right? So you can see they actually used vinyl siding. Vinyl is not even a reservoir cladding. It has weep holes. So why did this fail so much? They didn't even have any weather resistive barrier, no house wrap on this, no window flashings. I mean, they just put the vinyl right up over the sheathing. So again, that's a pretty extreme example, but you can see the stud there. You can see the insulation on the inside. You could stick your finger right through the sheathing. Now the picture on the right, don't have a ton of this type of work in the Potomac Valley. This was taken outside of Philadelphia. I don't know if you're familiar with all the stucco failures that have been taking place in the greater Philadelphia market. We call it the stucco apocalypse. But this house is 8 years old. And as the builder went through the neighborhood, they finished the last house and then they went back and started remediating the first house. And it was a $150,000 remediation project. Because the moisture was not properly managed, but yet the houses were built so tight that the walls couldn't breathe. And so we see this happening a lot, way too much. And then these pictures kind of show again the importance of the detail around the windows and the doors. And so we want to make sure that we're given the proper attention to manage the moisture in those areas. So one of the four-letter words in our industry that we don't like to hear is mold, right? So mold is bad. A lot of bad things happen with mold, right? We can have health issues, right? So that's not good. We all want to build healthy, sustainable homes. that are a good living environment for our clients. Mold also can equal litigation, which is also really bad, and we don't like that. I've heard it said that mold spores exist everywhere, and that's not necessarily a problem. The issue is when those mold spores have a food source, when they land on a damp spot. And so we want to make sure that we're controlling moisture so that we're not giving opportunity for mold and mildew to grow. So the solution, and this is the title of the presentation, drainage and drying. Now this slide, we call this the 4 Ds of moisture management. And I always joke, if you want to be a real hit at your next cocktail party, memorize this slide, because I'm sure it'll be a great conversation point for you. The 4 Ds of moisture management. Now the first one is deflection, and we're not going to spend a lot of time talking about that one here. Let's see if I can get my pointer up here. So deflection. So this is where, I just realized, I think the pictures are, do you guys see the, so I get rid of that, there we go. So you have the eaves here, right? So that's where the eaves come in, and they help deflect water, and that's effective. It definitely helps. In New England, you see really, really well-defined eaves. Doesn't really help with wind-driven rain, but it does a little bit of good, keeping moisture off of the exterior wall. But where we're going to live today is D2 and D3, which is drainage and drying. And then D4, durable components. We all want to use good durable components when we build. So here's another glamour shot where you could stick your pencil through the sheathing there. A couple of things that we need to assume. Perfect barriers don't exist. Water does get in. Now, this is a little discouraging, but that's not a problem. Water can get in if we manage it properly, right? So we could, I'll just give you an example. You could design the most impervious structure possible. You could caulk and seal, and there's not a single place for any water to get in anywhere. And then 6 months later, the homeowner, they move in and they decide, you know what, I want to put a mini split in this part of the house, right? I do want to run cable in here, or they do something different and they put a hole in that exterior wall assembly, and all of a sudden it's no longer a perfect barrier. And again, when we're using these reservoir claddings, it's introducing water in. So if we don't manage that water as it gets into the wall assembly, we will have problems. There's no way around it with how tight homes are being built now. So the solution, we want to create a gap between the primary and secondary barriers. Primary barrier being our sheathing, secondary barrier being our cladding. So most research says that 2 to 5% of water that hits a wall is going to get behind your cladding. And so we want to manage it. We want to provide a way out. And you can see here the example of a couple of different types of cladding with your drip edge and your flashing, but we just really want to let gravity kind of do its thing and get that water out of the wall. And there's some different ways to do that. So some of the traditional methods are using furring strips, or when we're talking about, with masonry, you have what's called that knuckle gap behind the brick veneer there. And those are good. But like a lot of the building industry, we've evolved, and there's some newer technologies out there. And that's where we start talking about our manufactured rainscreens, our different entangled mesh products out there, and drainable house wraps. And some of these are better. Some of them might be less expensive, but they're definitely faster. And so like a lot of products out there, they're designed just to make our building more efficient, the building process more efficient. So some benefits of building with a gap. The first one is it moderates the driving forces, specifically hydrostatic pressure. I'm going to talk about that on the next slide. And when you build with a gap, it lets the WRB do its job. Now, WRB stands for water resistive barrier. I'm sure most of you know that, which is a fancy term for house wrap. It's the technical term for house wrap, right? And so when we don't build with a gap, and we're just installing just a basic flat house wrap up on the wall, right? So just a building paper, or a felt, or a Tyvek, or just a flat house wrap, we're not allowing that WRB to do its job. We're kind of setting it up for failure, essentially. And that's why building with a gap is important. We want to increase the drainage and drying potential of a wall. And ultimately, again, we all want to design and build healthy, sustainable structures that are going to last and stand the test of time. So this slide, this is one of my favorites in the whole presentation. I wish this picture were a little bit bigger, but This picture is a 14-inch by 24-inch section of wall, and it's looking from the inside out through the stud cavity before the insulation is in, right? And in this little 14-inch by 24-inch section of wall, there are 20 nail holes right there. That's a lot. But this is realistic, right? So you have nails from your exterior foam board, you have nails from your house wrap, you have nails from your siding, you might have nails from trim, and all different factors here, but that's a pretty realistic picture. So if there are 20 nail holes in that little section, how many holes are we putting in a full addition or a new home build? And the answer is thousands, right? So this is a great quote. I don't know if you've heard of Dr. Joe Stiebrick. We quote him a lot. He's the founder of the Building Science Institute up in the Boston area. But basically what he says in this quote is, you could have thousands of holes in your house and it's not a problem if there's no hydrostatic pressure. In the last sentence here, I'll highlight, he says, you need to install the siding over a small gap to control hydrostatic pressure. So if you don't have that gap there, you build that water gets in there and it builds up hydrostatic pressure. And it's either going to go in or it's going to go out. And both can be bad, actually. It push out through the cladding, like directly out through the siding. This can cause premature siding failures, paint failures, warping, twisting, all kinds of bad things to our siding too. So the danger is that it could go either way, to be honest. So water takes the path of least resistance. And when we build with a gap, it reduces that hydrostatic pressure and lets water drain out. And ultimately, we want to create walls and structures that last and are sustainable. And so it's important that that hydrostatic pressure does not get a chance to build up behind our siding. So this slide, we're going to talk about the drainage and the drying. I'm going to take this in reverse order because it says drying first. So let's talk about the drainage, okay? So all you need for a drainage gap, a true drainage gap, is a 1 millimeter gap. It's not much. It's got to be a compression resistant gap. And that's enough to get 96% drainage efficiency. So it's going to allow bulk water, and I'll show you some pictures so you can visualize this, but it's going to allow bulk water to drain out from behind your cladding and out of the wall assembly. So that's the drainage side of things. And this is where we start talking about drainable house wraps, right? That's on the drainage. Now, ventilation drying, this is the rainscreen side of the thing, right? So we talk about what's the difference between drainable house wrap and a rainscreen. This is where we're starting to get into that. So a rainscreen is going to give you drainage, but it's also going to give you ventilation drying. It's going to create a continuous airflow in your wall assembly behind your siding. And in order to do that, you've got to have at least a 6 millimeter space. So a rain screen is going to be 6 millimeters, and a drainable house wrap is going to be 1 millimeter. And here's a picture that kind of shows you on a profile standpoint what that looks like, right? So 1 millimeter is not much, but again, 96% of water can just simply drain out with the use of gravity. And that's going to work. Drainage, the drainable house wrap is going to work on a lot of the projects that we're all specifying and building. So, so how rain screens work? In simplest terms, you know, when you create that 6 millimeter airspace between a cladding and the sheathing, you're creating a capillary break. So that neutralizes the ability for the wall to siphon water in, right? So water might get in behind our cladding. It will get in behind our cladding, right? So we have these reservoir claddings that absorb water and bring it in. But when you have that rain screen, it provides a full capillary break so that water can't just jump from the cladding directly onto the sheathing. All right, so building codes, everybody's favorite topic here. I'm not going to spend a lot of time on codes. They're important, and here's what I'll say about codes. We have a couple of folks in our office who are really good with all the different building codes. So if you have questions, don't hesitate to engage with us. I might not know the answer, but I could turn you on to somebody who does pretty quickly. But I'll just say a few things about the codes. Codes are catching up, right? So you remember that first slide that I showed, and it talked about energy on the left side of the slide. Had the picture of the window with the caulk gun, right? So codes have been good, pretty good on energy, but they're way ahead of where the right side of that slide was, which is moisture, right? And so the codes are now starting to catch up on the right side of that screen a little bit to where we need to be in balance. So Canada's way ahead of us when it comes to codes. So they actually call for a 10 millimeter rain screen pretty much behind every single cladding in the exterior wall. So Canada has taken this pretty seriously for a long time. This is their 2005 code. US IRC 2006, they're starting to talk about drainable wraps and being able to get water out of the wall assembly. 2009 starts to address some of the stucco issues that are out there and creating a designed drainage space. Oregon requires a drainable house wrap or some sort of a gap or a space. A furring strip or a drainage board is okay there too. But IRC 2021 is going to address this even more. So code compliance is going to become more and more important as we move forward. Another thing to consider too is our siding manufacturers. They're starting to catch on to this too, right? So a lot of the major fiber cement manufacturers, engineered wood manufacturers are starting to recommend or require a drainable house wrap. So it's always best practice to check with the manufacturer, right? We specify a specific siding project. We want to make sure that we're specifying the proper house wrap, the proper WRB and system behind it. So definitely check in with your siding manufacturer, but a lot of them are really starting to realize the importance of drainability behind their claddings. And candidly, that comes down to a litigation issue, right? They don't want to have issues. So they are starting to require that more. So what do you need for your project? So this is my good, better, best slide, right? So we'll start with the good. There's a flat house wrap. So this is just a quick review on what a WRB does, right? So a WRB, it helps reduce the amount of air and liquid water that can get in, but it's vapor open, vapor permeable, so water vapor can escape. So if water gets behind it, it can off gas and get through the house wrap, through the WRB, but it's going to limit the amount of air and water that get in. I'm not going to dive deep into perm ratings and the building science behind that, but I'll just say most building scientists agree a perm rating of 10 to 20 is kind of where you want to be. That's the sweet spot. Just open enough to let that vapor escape, but not so open that it lets too much water in, right? So that's the function of a basic flat house wrap. There's probably 100 of them out there, right? Your local lumberyard stocks their branded. Home Depot has a couple. There's Tyvek, there's Grip-Rite, there's Typar, there's tons of them out there, right? Flat house wrap. We have one too. So that's a good. Now the better is going to be a drainable house wrap, and that does everything that the flat house wrap does, but it gives you enhanced drainage capability. So that's where you get to the having that 1 millimeter compression resistant space that lets water drain from behind your siding. So it's going to do all the same things, but bulk water can also get out. And I'm going to encourage most of you that to use a drainable house wrap as your default spec is just, it's safe. It's just good building science, and it's really going to protect you in a lot of cases. And that's the better. Now, the best option is going to be rainscreen. Now, here's what I'll say about the rainscreen. You're never going to go wrong with a rainscreen. Is it overkill in some situations? Maybe, all right? So if you have, an addition and they're putting some vinyl siding on, rainscreen's probably going to be overkill in that case. But you'll never go wrong. It's never bad building science to use a rainscreen. And that's where you get not only the drainage, but the continuous airflow and maximum wall drying potential. One note is if you use a rain screen, you must also use the WRB. So the good and the best go together. I hope that makes sense. All right. So again, if we were in person, I'd make this more interactive. I'd ask some questions here. I always ask, what's the annual local rainfall for where we are? So in this case, I would say, what's the average annual rainfall for Annapolis, Maryland? And then I would ask the question, what's the average annual rainfall for Portland, Oregon? And a lot of times somebody will say, oh, maybe we're 20, 30 inches of annual rainfall in Annapolis, and maybe we're 80 or 100 in Portland, Oregon. The answer is they're actually about the same. And I know it's tough to tell from this map, right? But we're probably in the 42, 44 inch annual rainfall range in most of the geography where you guys represent on this call. And Portland, Oregon's about the same. Now, the rain comes differently, right? Portland, Oregon, it might rain, I don't know, maybe it rains 200 or 250 days out of the year there. And they don't get many of these major rain events like we do, where we get 2 or 3 inches at a time, and we have more wind-driven rain. But still, it's about the same amount of average annual rainfall. So why is that important? There's an organization out there, well-respected in the industry, called BEMI, Building Enclosure Moisture Management Institute. And what they say is that any area receiving more than 20 inches of annual rainfall should use enhanced drainage techniques in the wall system, especially if using an absorptive or reservoir cladding. So let's go back to the map. So what they're saying is whenever we specify or use a siding that absorbs water, and again, that's anything masonry, it's fiber cement, it's stucco, it's engineered woods. Most of the sidings that we're specifying are considered reservoir claddings today. If it's not vinyl, glass, or metal, it absorbs water. So what they say is any area receiving 20 inches of rainfall a year or more should use some sort of drainage behind that, drainable house wrap or something. 20 inches of rain or more is everything to the right of this line. So it's the entire eastern half of the US. So what BEMI suggests is we should be using some sort of drainage in our walls on every project. And they would say, even go a step further and say any areas receiving 40 inches or more should use rainscreen regardless of cladding material. So 40 inches or more, a lot of us are in that range right here. And they would say rainscreen, and it doesn't matter what kind of cladding it is, that they would suggest a rainscreen. So we definitely need to be considering these things as we design our projects. There's a lot of different factors that go into deciding what we use. Cladding is the biggest, and I know I've said it a bunch already today. If we're using a reservoir cladding, a siding that absorbs water, we've got to manage that water behind our project, or behind the cladding. Budget is always a factor. There's a slide later that'll talk a little bit more about that, and it's even more and more important to do this and to give this attention as our homes are more and more energy efficient. So I'm going to kind of move through some of these slides here. So some other things that we want to consider, does our house wrap resist surfactants? So I always ask in the presentation, does anybody know what a surfactant is? But a surfactant is anything that breaks down the surface tension of water. So imagine with me for a second, you take a water bottle and you put a couple of beads, you put a bead of water on your desk in front of you. That water is going to bead up, right? So I heard somebody once put it this way, and it's the weirdest expression, but it stuck with me. That water is going to stand up proud and tall. It's a weird way to put it, but it does. So now let's say you've got this nice little bead of water that's really tight and standing up, and then you put 1 drop of dish soap in that bead of water. What's going to happen? It's going to spread out and flatten, right? That's because the dish soap is a surfactant. Now, a lot of building materials that we use now have surfactants in them. That's fine, no problem. Anything masonry, fiber cement, wood is a big one, right? Surfactant in wood is called tannins. It's the same thing, the same surfactant that's in red wine. But what a surfactant does over time, it breaks down the surface tension of water and allows it to more easily penetrate a WRB or house wrap. So this picture on the right here shows an older project. It was a reside project where they took off the original cladding, and the house wrap had pretty much disintegrated, right? And that's because the house wrap was not surfactant resistant. So maybe that's the word of the day for us, surfactants, but it's important to make sure that we address that. We're not really using too many perforated house wraps anymore these days. And do we want to incorporate a drainage gap? Now, I'm a little biased, but I'm going to say, yes, we do want to incorporate a drainage gap in most instances. Is air resistance an important factor? There's more and more interest in the industry right now in creating an air barrier and having a product that self-seals around fasteners, especially to help us with energy efficiency and blower door tests and things like that. So installation, I'm not going to spend a lot of time in this presentation on installation, but I always offer this up. We'll dig in to your firm's spec, to a specific project at whatever level of depth you need or is helpful to you. And again, I know you probably hear this all the time from manufacturers reps, but we really do want to help you. We really do want to be a resource. So test us. You know, if you have a project and you're like, hey, I'm not quite sure what to do on this, or hey, there's these two materials that meet in this weird spot and I'm not sure how to deal with it, let us know. I mean, we have a team of folks who, you know, we can put together these construction details for you. We can analyze your existing construction details. We really are happy to help in any way we can. So don't hesitate to reach out to us. Just a couple of things, though, I will point out on this slide that are really important. When we have a drainable house wrap or a rain screen, our head of wall and our bottom of wall have to remain open. You've got to leave a gap there for drainage and airflow. And I've been on some pretty big projects where this detail was missed and there was massive failure, right? So water gets behind there, you got a rain screen, you think you're all good, but if you don't have the gap, that opening at the top and the bottom of the wall, water's not going to get out. And the top of the wall is important. If you imagine sticking your thumb over a straw that's in a cup of water, right? You stick your thumb over the straw, then you lift the straw out, that water stays in, right? So we've got to have that opening both top and bottom, super important. Stone and stucco, this detail is really important. I spend a little more time on this slide when I'm in, doing a presentation in the greater Philadelphia market, just because of all the pain in that market. The most important thing is here, you've got to have some sort of a sacrificial layer over your drainability, right? So here's your drainable house wrap, and then you've got to have a sacrificial layer that protects that drainable house wrap or rain screen. If you don't have that, and then all of your mortar, your mud, whatever it is simply going to go into your drainable house wrap or rain screen and render it useless. There's just no point in using it. Window flashings, definitely a critical failure point. It's the biggest opening in our houses. Again, I'm going to kind of breeze through these slides a little bit here. I just don't want to get really in the weeds with how to flash a window. But I will talk about it a little bit. There are multiple ways to flash windows, and there's not one right way. So I always like to say that. We like to promote a method that's called the cutback method. So I'm just going to walk through this quickly, but I just wanted to let you know, hey, there are other ways to detail a window, and we recognize it and acknowledge that. So with the cutback method of detailing a window, you want to cut the house wrap back a couple of inches from your rough window opening. And then you cut a top flap back at a 45-degree angle, and you can tape or tack that up. And then you do your sill treatment. A lot of folks will use a 9-inch wide flashing. There are some liquid flashing options out there right now that are really gaining some steam and momentum. And if you're using a 6-inch flashing, you're probably going to have to do some sort of detail like this. Create a little bow tie or do some origami out in the field. But it's important to address those bottom corners. So some job site pictures here. You can see the house wrap is cut a couple inches back from the rough opening. The sill treatment has been done. And now we're going to start putting the window in. All right. So we're putting the window in. And then once the window's in, then we can go, with our flashing on the sides. And what we like about the cutback method, one of the reasons we kind of tend to promote this one more than some of the others, is this window flashing is then going to hit all three substrates here, right? It's going to be on your window flange, it's going to be on the sheathing, and it's also going to be on the house wrap. And so we kind of like that, the fact that, it's touching all three substrates. Then you do your header, and then you put that flap down, tack it in place. And then I think the one thing this presentation doesn't show is we do want another piece of tape right here at a 45, kind of how that laser pointer is going. So basically what you've done is you've created a shingle effect down the entire window. And again, we acknowledge there are some different ways to do it. That's just kind of how we tend to recommend. So this is a powerful slide. I like this one because price is a factor, right? For most projects, there's some consciousness of the overall project cost. So flat house wraps and drainable house wraps. The important thing I want to point out here is when we're talking about a large renovation or addition or a new home build, the cost difference to go from a flat house wrap to a drainable house wrap is negligible. I mean, we might be talking a couple of $100 for the whole project. And it's going to drain 96% of bulk water out of there behind all of your reservoir claddings. Like that's kind of a no-brainer to specify a drainable house wrap as our default. Now, a rain screen, you can see, there's no question a rain screen is going to add some project cost, especially when you consider that you also need your WRB. So a good budget number, truthfully, for a rain screen system might be $1 a square foot. So that is going to add some cost. However, it is the right application in certain situations, right? So where we want to get into the rain screens is our wood and our masonry. So anything using wood or masonry, we really want to talk about a rain screen. Drainable house wrap is okay. Rain screen is going to be best for those cladding materials. So to conclude, to wrap things up here a little bit, water gets behind our cladding. It just does, and it's okay. It's not a problem if we manage it properly, right? But especially, again, reservoir claddings. Sorry, I've said it a lot. When we're specifying projects with reservoir claddings, we just have to acknowledge water is going to get in there. Codes are changing. The inspection community is catching up. Manufacturers are starting to be more and more concerned about water infiltration. There's a lot of attention on this topic today, and I think for good reason. There's a lot of different ways to handle, the moisture that gets into the building envelope, into the exterior wall assembly. There's not one right way to do it, but the fact remains we have to manage it somehow. And there's a lot of different factors that we talked about that would help us decide what to use when. So the learning objectives, to summarize, we want to build with a gap within the exterior wall. So between our primary and secondary barriers, our sheathing and our cladding, we need a gap. We talked about the difference between a drainable house wrap and a rain screen. And later in the product portion of the presentation, of course, I'll show some more pictures that maybe will help clarify that a little bit further. And we talked about when we want to use which and how we decide how we're going to manage moisture in our walls. And talked a little bit about installation, but again, readily available to help on the installation side, if there are things that come up in the future. So I'd like to pause at this point and ask if there are any questions. I'm actually going to stop sharing my screen here for a minute, I think. So what questions do you have? Hopefully I didn't put everybody to sleep.
Hi, I have a question. Dan Hayes here. If you have, instead of a clad wall, like a brick veneer, if you have a solid masonry wall, do you still need the gap and the water barrier on the inside of either a 2, 3, or 4 wide brick wall?
Okay, so the question would be, so the brick, it's going to be a solid brick exterior. What's behind the brick?
Whatever interior finishes or whatever you have in the rest of the house, because it's actually a masonry structural wall. I have a 1908 house as well, but it's sort of solid 12-inch brick masonry exterior walls. And so the question is, do you need to deal with infiltration through that thickness of brick as opposed to a brick veneer?
Yeah, likely not. And it's because of the thickness, right? So does brick absorb water? Yeah, of course it does. But when you're talking about a 12-inch thick wall, or some of the older homes built in the early 1800s, you've got 2-foot thick exterior walls. It's going to take a lot of moisture getting in there for that to absorb all the way through. So in that case, there's probably not anything that would be necessary in that case. I see a question that came in the chat, and this is a great one. I'm gonna address this when I get it all the time. A lot of builders are using zip system sheathing with a built-in WRB. How do any of these systems work with zip? And that's a great question. Thanks for that. So zip is fine from a WRB standpoint, right? So good building science, and gosh, I see more green going up than I do brown these days, as homes are being built and remodeled. So my only concern with zip, well, there would be two with the zip system specifically. One is the reliance on the tape. So if the tape's being installed properly and rolled out, and then we're good there, you know, from a building science standpoint. But it doesn't provide a moisture barrier or a drainage gap, right? So you could put a drainable house wrap directly onto zip, no issues whatsoever. You could put a rain screen directly onto zip, no issues whatsoever. So it comes back to what is the cladding that's going on over that. And if we're using a reservoir cladding like a fiber cement or a wood, I would get pretty nervous putting that directly over zip. So hopefully that helps. Another question that came in, how often does a third trade come along? I'm already laughing, or smiling, I guess I should say. How often does a third trade come along after the windows and cladding have been installed and caulk and block the drainage opening at the bottom of the wall? I hope not often. The reality is, you know, it's tough because, you know, we can only control so much of the process, and then what's done after the fact, we just don't know. And so the attention to detail is crucial, but is that getting all the way down to the third trade, to the last guy coming through? So we know that's bad building science. It's just a struggle. How do you keep that from happening, right? So appreciate that question. Justine asked a question in the chat. The detail of the top of the air gap that was shown seems vulnerable to driven rain. How much overlap is needed, especially with cedar shingles? And so I think, Justine, and speak up if I'm misrepresenting the question, but I think the question is in that top of wall detail that we looked at, having that gap there. Hopefully that's correct. A lot of times that gap can be hidden behind, you know, a trim piece. I see you unmuted yourself.
That is my question at the top of the wall. But it seemed as though, particularly when building along seashores, that would be a very vulnerable. How much do you have to protect? Would it be a full shingle or a half a shingle? How do you make sure you've achieved the purpose?
Yeah, that's a good question. I'm going to try to share my screen again here if I can. And I'm going to go back to the presentation. So let me see. Can you see the screen okay?
Mm-hmm. Yes.
Okay. So let me go back to that slide. Maybe. There we go. So let's take a closer look at that here. And this is something, Justine, too, that we could take, you know, on a project by project basis and look a little more specifically at. But here you've got your finish board, right? And so if this is a cedar, like if that's a cedar shake or a shingle, you know, it looks like there's maybe 3/4 inch of that cedar shingle is covered. On the coast, I mean, maybe you want to beef that up a little bit, you know, just to protect it even further from those wind-driven rains. It's a good question.
Thank you.
Mm-hmm. Other questions? Sorry for the, hope not giving anyone seizure by flying through these so quickly. Get back to. All right. Well, if there's no other questions on the building science side of things, I'm going to move into the Benjamin Obdyke specific portion of the presentation. Before I do, though, again, I'll mention, please email me with your name, AIA number, and firm name if you need credits for today's course or a certificate of completion. And all of my contact info is in the chat, so you can grab it there and reach out to me anytime. So I'll jump into the Benjamin Obdyke portion of the presentation. We've been around since 1868. So we've been in moisture management for 150 plus years. And the way we got our start as a company was by holding the original patent for the corrugated downspout. So we've always been about managing moisture in one way, shape, or form. And for about 130 years, we were pretty much a metal company. And those are the products that we used to manage moisture. Now, we've sold off all of the metal business, and we're focused entirely on ridge ventilation for the roof And then of course, today our focus has been the wall assemblies and on the products that we'll talk about coming up here. The other thing I like to point out on this slide is Benjamin Obdyke had a pretty cool mustache. And we do use that in our marketing pieces. So if you ever see a marketing piece or on our website, you see a mustache, at least you'll know why. So our warranties. With architects, I love to talk about our warranties. I've been in the building industry about 15 years or so, and there's a lot of warranties out there that are pretty thin, I'll be honest. You know, maybe it's just in case of manufacturing defect, or it's a year, or we'll give you a product warranty, but not a system warranty. Just a couple of notes about all of our warranties, all of our system warranties. Number one, they are for labor and materials, right? So that's important. If there's a system failure, we're going to pay for labor and materials to replace the system and any other materials that were damaged as a result of the system failure. Number two, our warranties are performance-based, and that's a big deal. So if you take our 35-year rainscreen system warranty and you remove that cladding in 34 years, you could test the system and it's still going to perform up to all testing standards. So it's a performance-based warranty, and it's also transferable. So our warranties hold teeth. I mean, they're real. They're great warranties. So as I go through our product presentation, everything's going to be organized by system, okay? So you're going to see a slide like this, and then you're going to see a slide like this that tells you what that system warranty is and the components that go into it. And then we'll have slides to talk about each of the products. I hope that makes sense. So the first system I want to talk about is our drainable house wrap system. And this carries a 20-year performance-based system warranty. And the products that go into this, you have to have the WRB, which is our HydroGap. You have to use one of our flashing products called HydroFlash. And there's 3 different ones. We recommend HydroGaps installed with cap fasteners. So a lot of you might have seen this. This product has been out for a long time. It was the first drainable house wrap to come out. And has been really successful for us. So in fact, a lot of people know the HydroGap name, but not the Benjamin Obdyke name. I'll walk in and introduce myself as being from Benjamin Obdyke. I've never heard of you. And then I'll show them HydroGap. Oh, I know HydroGap. That happens a lot. So this is our leading product in this space. And it has these, if you can see in that picture, it has these blue dots or spacers. Those are compression resistant. And that's really important because there are some drainable house wraps out there today that just simply aren't compression resistant. So when you put the siding on, the drainable house wrap flattens out, not super drainable at that point, right? So you've got to have that compression resistance. And that allows 96% of bulk water that gets in there to simply just drain out of the wall assembly. Really nice, smooth, easy product to use. Put it up with a cap fastener, 5, 9, and 10-foot widths. Contractors love the 5-foot width. It's so easy to work with in the field. One guy can do it. This can be installed any direction. Of course, you know, the pictures, we like to show the logo and the writing right side up. You can install it upside down, up and down, diagonal, doesn't matter. It's going to work. This is a good, strong, durable house wrap. 120-day UV exposure. And all of our products you're going to see on the right side here, the vapor permeability. I talked about that a little bit in the presentation. 10 to 20 is the sweet spot from a building science standpoint. So we're at 16 here with the HydroGap. So to get the system warranty, use HydroGap with one of our HydroFlash products. And there are 3. You'll see 2 of them here. 2 of them are tapes. One of them is called HydroFlash UV+. One of them is called HydroFlash GP, which stands for general purpose. A couple of things about these tapes. All of our products use an acrylic adhesive, and that's really important. Acrylic adhesive, it's the best adhesive technology on the market today. And I'll spend a little more time talking about that in just a minute. They are pressure activated. So we want to make sure that we're rolling out and applying some pressure to our tapes. This product, the UV+, I'd put this up against any tape in the industry today. Really super workable in the field. It's got a little bit of flex to it. It's not a flex tape, but it's got a little bit of flex. Strong, durable, 365-day UV resistance. This is the cool part though. It's got a perm rating. So there aren't many tapes on the market today that are vapor permeable. So if any water does somehow get behind the flashing tape, maybe it's not rolled out, you've got some air pockets where water can get in, it can get out. And that's important. So this tape breathes, which is really cool. And then HydroFlash GP is general purpose, and they're both going to work with our system warranty. So again, I always tell folks, if you're going to use HydroGap, this is a 15-year product warranty. It does not cover labor and materials to replace. If you put one of these around your windows, now it's a 20-year performance-based warranty that covers labor and materials. So it really just makes sense to kind of think in terms of systems with our products. So that's our drainable house wrap system. Now this one we're super excited about. This is called HydroGap SA. It's a 20-year system warranty, and SA stands for self-adhered. So there's a lot of interest in the market today with self-adhered products. So I'm going to talk a little bit about why ours is different from anything else on the market. First and foremost, it's drainable. It is the only self-adhered drainable house wrap on the market. There will be others, I'm sure, but for now, this is it. We launched this product back in January. We're on pace to quadruple our projections for the year. Now, part of that is the industry is just booming right now, which we all understand, but there's a real interest in this product. We use an acrylic technology for this product. And so I'm going to get in the weeds just stick with me for 1 minute about acrylic adhesive and why it's better than other adhesives. The other main adhesive that's used on the market today is butyl. And a lot of tapes and a lot of self-adhered products out there use a butyl adhesive. Acrylic is much, much more forgiving to work with. Okay, so with a butyl product, if you start to get it up on the wall and you get it in the wrong spot, or it's a windy day, or it gets stuck to itself a little bit, you've got to cut it off and start over. However, with an acrylic product, if you start to get it up on the wall, you can actually adjust it. And I know that sounds like a minor detail, but we've converted builders who have been using other products so fast when they realize how easy this product is to work with. So the ease of install is just through the roof on this product, and that's because of the acrylic adhesive. One other really huge and important benefit with an acrylic adhesive is acrylic adhesive is permeable, meaning it can breathe. Butyl adhesive is not. It's not vapor open. So other products on the market that are self-adhered use butyl, and the only way they can get a perm rating and allow their product to breathe is to splotch the adhesive on. It's not continuous. So when you're shooting fasteners through this product, you may or may not be hitting the adhesive with a butyl product. I hope everybody's still with me. I'm in the weeds, but I'm almost done. However, our product is 100% continuously coated because we use acrylic adhesive and we can coat it, and it stays vapor open. It can still breathe. So when you're specifying a product where you want a self-healing quality, where you want every single fastener that goes through this, you want to seal around that, you want something with an acrylic adhesive. It's going to give you certainty that every fastener is going to self-seal. With a butyl, it may or may not. I hope that all made sense. Sorry, I'm off my soapbox. This product, again, it gives you that 1 millimeter space. It gives you 96% drainage efficiency. It's going to adhere to any substrate, CDX plywood, CMU block wall, without the use of a primer. The level of friendliness from an installation perspective is just tremendous. So guys just love installing this product. And again, it's the only drainable self-adhered product out there. So I won't spend nearly as much time on any other product, but this is our new one, and it's really taken off in the market. It truly has. So I'll go back a slide. To get the 20-year system warranty, you can use any of our HydroFlash products. So that would be any of the 2 tapes that we talked about earlier, or HydroFlash LA, which is a liquid applied flashing. A lot of interest in liquid applied products out there now. Comes in a 20-ounce sausage pack or foil pack. Now, I'll say this, a lot of people use this in different ways. People have been discovering different uses for this product. Some people, they'll use this just in their sill. That's probably the most common application we see, just in the sill. Some people will use it all the way around, all 4 sides of the window. Some people will only use it on curved windows, or those weird hexagon shaped windows, geometrically challenging areas where maybe it's hard to use tape, right? So this is a great tool to have for those applications. This product has a perm rating. So again, if water somehow gets behind your window flange, it's going to be able to breathe and get out. So that's our HydroFlash LA liquid applied flashing. So those are our drainable house wrap systems. Now our rainscreen systems, and I'll go faster here, they carry a 35-year system warranty. This is an industry-leading warranty. Again, performance-based, labor and materials, if you use all the components on this slide, which would be our flat wrap, any of our slicker products, which I'll talk about. And again, these three we've talked about already, any of our HydroFlash products. So these are the three components. So a flat house wrap, and again, we talked about this earlier, doesn't provide any drainage, but behind a rain screen, you have to have that WRB. So our flat wrap, great tear and wind load resistance. It's a tri-laminate design, so it's 3 layers. Kind of think of this as something like Gore-Tex, 3, 5, and 9 foot widths. Great product to work with. And you would put the Slicker Classic over it. So this is the original rolled rain screen. We were the first to come out with this product. We like to be an innovator in our space. It's been on the market for, I should know exactly what year, but probably 20 years, 15 to 20 years. I think it was 2002 we came out with this, but this is going to be great behind cedar shingles, anything where you need a rain screen. So this gives you that full 6 millimeter rain screen where you get continuous airflow. Now, another option, I'm going to go back to that last one, but another option is Slicker HP. Now, I like this product because it basically combines your flat wrap and your slicker in one roll. So instead of wrapping the house twice, you can wrap the house once. So it's got your house wrap and your rain screen together in one roll. So it's a good labor savings. So just something to be aware of. And again, to get the system warranty, you want to use one of our flashing products with this. This product is like a slicker on steroids almost. So Slicker Max, I love this product. So we came out with this. You can see there's like this filter fabric on it. It actually is designed to go on the outside. And we came out with this for our stone and masonry projects. And the purpose is that filter serves as a sacrificial layer. So when you're slinging the mud and the mortar's going up on the wall and all of that, it's not getting into your rain screen and clogging it, but it's protecting it. But one of the other cool things that filter fabric does for us is it gives us great compression resistance, right? So if you're using a product like James Hardie or LP Smart Side or even a cedar bevel siding, having that extra compression resistance is really, really a nice feature. Just helps everything lay on the wall really, really nicely. So those are our rain screen systems. Now this is kind of newish here in the US within the last several years. This is a European look, right? An open joint system. We're seeing an awful lot of this, especially in some of our more modern metropolitan areas. And that's using decking as cladding, whether it's a composite decking, whether it's a wood decking like Ipe. We've even seen some different creative materials being put on the wall with an open joint with a gap. And we have a system for it. It's a 25-year system warranty. And it utilizes 3 main components. We've got our InvisiWrap, we've got our Batten UV, and HydroFlash UV Plus, which we already talked about. And this entire system is UV stable. So 365-day UV exposure before the siding is on. And you can gap this by up to 2 inches. So the earlier question that came in about that head of wall detail made me think of this a little bit. When I first saw this as a siding option, I thought, that's crazy. You're just inviting water to get behind your siding by leaving that gap open. And the person who I said that to commented about that too. They said to me, they said, Karl, you're thinking of your siding the wrong way. Siding is decorative. It's aesthetic, right? What goes behind the siding is what really counts. And so we've got a great system for this. Our InvisiWrap, it's a black, of course, no writing, UV stable product, great tear resistance and water holdout. And then you put a UV stable batten strip over it, right? That provides continuous airflow. Now this isn't structural. You've still got to fasten through into your sheathing, but this can be installed vertically, horizontally, at a diagonal. Doesn't matter. Great system. And then you use our HydroFlash UV tape to go with it. And then the last thing, and then I'll wrap up, is for cedar roofing. So we came out with this product, I think this was 1997, 98. So again, we had the original patent for a product like this, but you put up your felt paper, and then you roll this out, and this provides your underlayment, your continuous airflow, your gap underneath your cedar. Man, I've sold a lot of cedar shingles and shakes in my day. Beautiful product, you know, and they come with a 30, 40, 50-year warranty even. And if we're not creating a drainage gap underneath there with continuous airflow, that product's going to prematurely rot in 6 to 10 years. This is just it's super important to make sure that that product can breathe. And then we've got a rapid ridge product. This goes under your prefabricated hip and ridge. It's specifically made narrow to fit under that hip and ridge. And when you use those two together, you get a 35-year system warranty. So again, we think in terms of systems. So that is that's my presentation. Sorry, I think I might have gone a minute or two long, but I hope that was helpful. I'm gonna just see if there are any other questions that I missed in the chat. And then I'm gonna stick around here. So if anybody has questions, I'm happy to stick around for a little bit and answer them. But yeah, we're done. So I really appreciate everybody jumping on. I hope that was informative and helpful, and call anytime if I can help. So Eric had asked a question, are using water absorptive cladding better than water retarding materials? Guess I'm not familiar, Eric. Maybe we can chat about that a little bit more, what water retarding materials are. Other than, you know, a metal product or something like that. I'm not sure what a water retarding material would be. So happy to stick on if you want to discuss that a little bit further. Any other questions? Yes, Young, did you have a question?
Yes. So far, I'm glad that you introduced a lot about the technical issue about the the preventing the moisture while rain things. And I'm just curious, is this material for the residential building only or commercial use also?
Yeah, good question. So there are some limitations with commercial use. And what I would say is most of that is related to UV resistance, right? So in a typical residential or multi-family project, our products go up on the wall, and then the siding is going to be up, you know, within a month or 2 months, maybe 3 months, right? But in a commercial application, a lot of times that WRB is exposed longer. And so some of our products, like I didn't hold my samples up when I was doing the presentation, I should have. Some of our products like this one here, right, our rainscreen product, this has a 30-day UV resistance. So you wouldn't want to put this product up when you know that, hey, that siding's not going to be on for 90 days or 6 months. That's going to create a problem. So that's really the limitation when it comes to the commercial side of things. I hope that makes sense.
Okay, sounds good. And is that material is kind of a fire resistant material, or it's a flammable material?
The decking material?
No,
Yes.
rainscreen. I'm sorry.
Oh, the rain screen. Yeah, good question. All of our products are Class A fire resistant. Yep. So they all have that Class A rating.
Okay, thank you.
Yep, you're welcome.
I'm just surprised about this product helping residential building in East Coast. And in good old days, if you go back 30, 40, 50 older building, our thick brick wall system in East Coast building is we have a typically 2-inch air space to eliminate all the water penetration. Now we have a water, the rain screen, we can reduce saving about 2-inch wall thickness. Isn't that awesome?
Yeah, it's amazing how the industry has changed over the years, and that's the thing, you know, as we change one thing in the industry, it has such an impact on everything else that we do, you know. And so if code changes in one area, how does that affect other areas? So for example, the 2021 IRC is going to specify exterior foam insulation on all residential projects. Well, that's significant. How does that impact how we build windows, you know, and how we install our window trim and those window details? Do we have to pack our windows out? Do we have to get an extension jam now for every single window? And so one thing impacts another thing, which impacts another thing. And that's what's fun about this industry. There's a lot to keep up with.
It is. Thank you very much.
Yeah, thank you, Jan. Question came in on the chat. What is the detail at windows when using the rainscreen system? Does the trim or window need to be furred out at all? That's a good question. And I actually kind of just talked about that without knowing it. But yeah, so yeah, you do need to pack the window out just a little bit, just to kind of accommodate for that little bit of an extra space or gap that's there. And we can provide construction details for you on that too, if that's helpful. So feel free to reach out on that. All right, if there are no other questions, I'm going to stop recording here, I think, if I can figure out how to do that. Maybe I can't.